Hello and welcome back to the CCENT journey with me, Ryan, and in this section we're going to continue with the domain name system part 2. First up, we're going to jump into Packet Tracer and configure a network very similar to the one we were talking about in the previous video to make sure we really do understand what's happening with the DNS resolution and how that may affect our network. And then we're going to look at the DNS configuration on an actual Cisco. So what does the IP domain lookup, the IP name server, and how do you statically set DNS entries? For those who don't know, you can contact me here on YouTube, on LinkedIn, or Twitter. So before we jump in and have a look at some DNS configurations on a Cisco device, I thought it'd be great to just spend a few minutes to actually understand what we talked about in the previous video by putting it into Packet Tracer. And you can see in front of me that we have a network all set up. It's pretty straightforward. We have a network on the left hand side over here for the 192.168.0.0/24 and a network on the right hand side for the 172.18.0.0/24 and a single router in the middle splitting up those broadcast domains. We have two servers over on the right hand side. One is a DNS server and the other is a web server displaying a web page, and on the left we have our two hosts. Our two hosts are receiving a IP from DHCP, which is configured on the router, and part of DHCP is the options, and part of those options we've enabled DNS. So the DNS server IP address will be relayed to the host, and the host will know who to resolve any queries against. So in this example we've actually got www.ryan.com, and this is going to resolve to our web server. So in order to find that out, the PC has to query the DNS in order to find the IP address mapping to domain, which is the A record which is stored on the DNS server, in order to find the final destination. So just quickly, let's have a look at some of the verifications we've got. Up first, we need to make sure our PCs are actually getting an IP address. So we can see here that we've got DHCP enabled. We've got the first usable IP range, IP in that range, sorry, with the default gateway being 254, which is the gig 00 interface, and the DNS server is 172.18.0.1, which is down here. If we go over to our DNS server and go onto services, and we can see, if we go to DNS, a record has been created, and the A record says www.ryan.com point towards 172.18.0.2, which is this server at the top, because we're currently on this server at the bottom. We got the DNS service is on, and if we go to this server at the top, look at the services HTTP, and if we look at the index dot, is it the index? Yeah, the index.html, and you can see that my name has been inserted up the top there. So what we're going to do is go on to this here, and we're first of all going to check what DNS settings we've got through the IP config, and we're going to use the /or to find the DNS servers. We're going to make sure we have communication with our DNS servers through ICMP. It's going to take a while to resolve. Brilliant. And now let's see, does it do the resolution? So it gets a response from somewhere. But what if we were to actually browse to it? And you can see that the web page is come back. So again, that's kind of just demonstrating what we went over in the last video, where the PC needed to communicate with the web host, or where the server's stored, the web server I should say, which is over here. And in order to do that, it had to find out the final destination, and all it had initially was the fully qualified domain name, and it needed to do the A record lookup down here in order to redirect its traffic to the correct location. So going on to a different example, you can see a topology very similar to what you're used to, but notice something. I've actually have two routers instead of the one router. And let's understand how that changes the actual network. First of all, PC1, it can still speak all the way down here to the DNS server and resolve to the web server. In fact, if we bring across the PC and browse through our configured website, it still works. But let's change our attention to the Cisco's and understand how DNS works for them. So we know that traffic passes through, great, but what about the Cisco itself? What if we have DNS resolution required on the Cisco? Now first of all, let's have a look at router 1. Router 1, for its configuration, has a DHCP pool, great, and a couple of interface configurations, and a default gateway to push all of its traffic towards router 2. That's all the config it has. So if I were to type in something like ping ryan.com, it says I'm trying to translate ryan.com and I'm using the domain server. Well, you ain't gave me one, so I'm going to use my broadcast layer 3, which is to the all 255 out of all the interfaces, to try and resolve it. And it fails because, of course, if it goes out of gig 01, it will hit 2 and 2 will stop the broadcast, and it would go out of gig 00. The switch will get it, the switch will send it to PC2 and PC1, and both of them are not running any DNS services. So no one responds, and ultimately it gets stuck into this state where it's unable to resolve it. What if we were to go to PC2? Router 2, and look at its configuration. So this one has no DHCP pool. It has a default gateway back to router 1. I mean, this is not a great design, but it does the trick for the lab. And of course, it has the interface configuration. So what happens on here? It works. Why does it work? Well, it works because our DNS server is outside this layer 3 interface. So the router sends its broadcast traffic out of gig 00 and 01, but 01 has a DNS server that is able to resolve the traffic for it. Therefore, it's able to resolve on router 2, but not resolve on router 1. So let's look into what configuration changes we need to make on router 1 in order to allow it to resolve any DNS it requires, just like router 2. Well, we have to tell router 1 where to go in order to resolve DNS. So in this instance, what we can do is give it a name server, and we give it the name server of the destination down here, because if we check with router 1, is able to reach the DNS server. So we can give it the name server of, and this will ensure that anything we type in the ping for www.something, or even if I type in test, notice what it was trying to do. It tries to translate it towards the domain server, the name or name server, whatever you want to call it, the DNS server of 172.18.01. So now if we go back to our original question, I can now ping ryan.com. So it's important that we have DNS set up on our end host, and if required, set up on R1 and R2. Now the reason DNS is pretty useful is because you can also create local entries. So on router 1, we can have it where I type in R2 and it telnets to R2. And on R2, I can have it where I type in R1 and it telnets to R1. So let's give that a go. And what we can do there is we got two choices. Either we make some DNS entries on our server, or we can make some local entries on the routers themselves. And we do that using the IP host command. And we're going to give it the IP address of the other box. So here we've said the IP host of R2. So if I just type in R2, you need to resolve it to 10.0.0.2, which is the gig 00 interface of router 2. So if I type in now R2, there you go, it's tried to open a telnet session to router 2. However, it's been refused because router 2 is not set up to accept any telnet. We don't have our VTY configured, we don't have it locked down, we don't have anything configured there. That's why it's failing. But what we can see is a few things. First of all, it resolved correctly because of that local resolution I've done, and you can see it tried to telnet because it tried opening an actual session to that router. So some of the things we need to remember then. First of all, we need to remember how DNS works as an overall technology, which we picked up very heavily in the last video. We need to understand how that applies to our networks today and the problems it may cause for us. Like, for example, you might be able to ping an IP address, but not be able to ping the actual website name. And that may indicate a DNS issue. We need to be able to configure the DNS on a router, both using the IP name server command to redirect our local DNS queries, and to be aware that we can set up a IP host, which is ultimately a static DNS entry locally configured on the router. Now lastly, there's one other command that we need to be aware of, and that is how to turn off and turn on the translation. So for now, if we again try doing ping.ryan.com, it works, and that's because we've done our configuration as previously explained, but it's also because we've got the IP domain lookup command on. So that means the IP domain -lookup is turned on, and if we were to turn it off, the translations would fail because IP domain lookup allows the DNS resolution to happen on the router. Now interestingly, with packet tracer, if I now do the ping to ryan.com, it still works, and it shouldn't work because no IP domain is actually turned off. So we've turned off DNS resolution, but it works. Maybe it's because it's cached, but what I've seen is that if we actually turn the router off, turn the router on, let's have a look at what we get then. So no IP domain lookup, and we can see that it says translating w.ryan.com. There's no recognized host running. So now whatever we type in is unable to do any translation on that because that translation is turned off. And then if we do the IP domain lookup, it will then try to actually translate what we put in the console, but we know obviously there is no translation for this here. The original translation now works again. So why that happens on packet tracer, maybe it's just some cached DNS, or maybe it just requires the device to be turned off, turn on. On a physical device, if you do the no IP domain lookup, it instantly stops working. But nonetheless, long as we know about these commands, we should be fine. So just to recap, we do the IP domain lookup and no IP domain lookup to turn it on or off. And when it's on, we can give it a static host translation, or we can give it a name server to query against in order to try and resolve something. Now the reason you tend to have it turned off in most environments is because DNS is not required on a Cisco, but there's no harm to have it turned on. The only thing you need to be aware of is obviously it's another service running on a router, and therefore any potential vulnerabilities that come up with DNS may or may not apply to the router you're running the DNS service on. So it's just something to be aware of. So just quickly before we end this video, I thought I'd add this in. I've gone ahead and built a Cisco in a lab environment which has internet connectivity. You can see that I'm able to ping out onto the internet, and I have the name server set up for 8.8.8.8, and I have the IP domain lookup command turned on. Now, what would happen if I turn off the IP domain lookup? And then run that ping again. Interestingly enough, just like we see in packet tracer, the simulation, it works. However, what if I were to try a different website? It fails. So it's most likely just a cache as expected previously, but in the packet tracer scenario, we only really had one website. I mean, we could have added multiple static, multiple A records to simulate this, but I thought it'd be good to just jump into some live equipment and test it for us anyway. So the IP domain lookup does turn off the DNS resolution as expected, but of course anything in its local cache would remain in its cache. Okay, so that's all we've got time for in this lesson. Just to go over what we talked about, we first of all labbed up the conversations we had in the last video. So we made sure we had a DNS server with an A record, and then that A record was over to a web server, and we had a client set up with DHCP. It received the DNS server, it was able to query it, and then resolve to the correct web server. Really important that you do the go play at the bottom here. Go to Packet Tracer, set up the same scenario and configure it yourself. Will I give you the Packet Tracer configuration files? No. Part of this process is to go and do it yourself. If I gave you the file, you're not going to learn anything. We then looked at these three main commands. The IP domain lookup. So we said that if this was off, then the local router will not do any DNS, and it will simply just say that it's a not recognized command. If we turn it on, it will then perform or attempt to perform some sort of DNS lookup. By default, it will go to the OR 255, and we've seen that initially, but we can specify an IP name server or a DNS server for the router to query against. We can also set up static one-to-one sort of translations, where if we type in router 1, it goes to 1.1.1.1, and then that's something that we can use to override any entries in the IP name server, or it can be used to ease the administrative overhead of managing multiple devices. Because if you're in a large network, it's easy sometimes to obviously remember the host name of the individual devices rather than the actual IP address. But obviously, if you're in a large environment, normally these types of records would then sit on your DNS server rather than local as individual host files. But at least you know that option is there. I hope this has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.